This is lesson 4-9b from the Algebra Readiness textbook. For today's lesson, we are going to learn to compare and compute with numbers in scientific notation. You can compare and order numbers using scientific notation. The way that we do it is first compare the powers of 10, complete your notes please, and then we're going to compare the decimals. Let's give this a try. I have 3 numbers. Now, notice some of these are not written in proper scientific notation. So our first step actually needs to be to put them in proper scientific notation. This is a review skill from yesterday's lesson. The decimal belongs between the 6 and the 4. The way it currently is written, I move the decimal 8 places to the right. But to place the decimal where it actually belongs, I've already moved it 2 of those 8 places, leaving 6 places remaining. The next number, 312 times 10 to the second, the decimal is currently here. The decimal should be between the 3 and the 1. From where it's currently written, I move the decimal 2 places to the right, but putting it where it should belong, between the 3 and the 1, adds 2 more places. The last number, 58 hundredths times 10 to the 7th, the decimal should be between the 5 and the 8. Now, from where it currently is, I would have to move the decimal 7 places to the right. But I would like to put it between the 5 and the 8, so that's one of the places. So 10 to the 6th power. Now let's compare the 3 numbers. Let's compare the powers of 10 first. The one with the least power of 10 is my first number. Then I see that this 6 and 4 tenths times 10 to the 6th and 5 and 8 tenths times 10 to the 6th both have a power of 10 to the 6th. So then I compare the decimals. Well, the next decimal in line would be 5 and 8 tenths, then 6 and 4 tenths. So comparing these numbers, I would write 3 and 12 tenths times 10 to the 4th is less than 5 and 8 tenths times 10 to the 6th, which is less than 6 and 4 tenths times 10 to the 6th. There we go. All right, try these 2. Compare and order from least to greatest. Make sure you put in proper scientific notation first. Hopefully you've worked these problems. You should have gotten 5 and 26 hundredths times 10 to the 9th, 1 and 83 hundredths times 10 to the 7th, and lastly, 9 and 8 tenths times 10 to the 11th. Now, first I want to compare the powers of 10, and in this case, this one's first, this one's second, this one's third. To write my answer, I would write 1.83 times 10 to the 7th is less than 5 and 26 hundredths times 10 to the 9th, which is less than 9 and 8 tenths times 10 to the 11th. Good. The next problem. This one gets a little trickier. I need to compare these and using their, let's put these in proper scientific notation first. 8 times 10 to the negative 9th is already in proper notation. 1 and 47 hundredths times 10 to the, now originally this means move it 7 places left, but I already moved it one of those places, so now it's 6 places left. The last one should be between the 2 and the 2. Now I need to, the exponent tells me to move the decimal 10 places left, but from here, so from where I moved it, now I need to move it 11 places left. Now Now we're ready to compare these three numbers in scientific notation. Remember, with negative numbers, the bigger the negative it is, the smaller the number. So my smallest one would be this one, then this one, then this one. Written 2 2/10 times 10 to the negative 11 power is smaller than or is less than 8 times 10 to the negative 9th, which is smaller than 1 47/100 times 10 to the negative 6th. You can also multiply numbers in scientific notation using the rule for multiplying powers with the same base. So if I want to multiply 3 times 10 to the negative 7 and 9 times 10 to the third, express the result in scientific notation, I'm simply going to multiply the numbers. 9 times 3 is 27 times 10 to the, then I have the same base here, 10 to the negative 7th times 10 to the third. See, they have the same base. When they have the same base, you simply add the exponent. Negative 7 plus 3, which is negative 4. 27 times 10 to the negative 4. But then I need to make sure to write the answer in proper scientific notation. So my answer should be 2 7/10 times 10 to the negative 3. Pause the video and try these two. Come on back to compare your answer to mine. All right, I'm using the commutative property, which allows me to say 4 times 6 first, and then 10 to the 4th times 10 to the 6th. 4 times 6 is 24. Then 10 to the 4th times 10 to the 6th is 10 to the 10th. This is not written in proper scientific notation because my 24 is not a number between 1 and 10. The decimal should actually go here. From where the decimal is, I need to move 10 places to the right. So the new one, I move 11 places to the right. Letter B. 7.1 times 8 times 10 to the negative 8th times 10 to the 4th. All right, so I need to do a little side problem. 856, so 56 8/10 times 10 to the, now I can add the bases, add the exponents. Negative 8 plus 4 is negative 4. So from here, I move the decimal 4 places left. That's what the exponent tells me. But we know that the exponent actually belongs between the decimal belongs between the 5 and the 6. So that's really scooching it 1 place left. So 5 6800 times 10 to the negative 3 is how you multiply those numbers together. The Great Pyramid of Giza in Egypt contains about 2 3/10 times 10 to the 6th blocks of stone. On average, each block of stone weighs 5 times 10 to the 3rd pounds. About how many pounds of stone does the Great Pyramid contain? Hopefully you see that this is a multiplication problem. When we multiply this, we're going to multiply the numbers together first. Then we're going to multiply the powers of 10. 2 3/10 times 5 is 11 5/10. I have the same base, so I add the exponents. Then I need to write it in proper scientific notation. And that would mean 10 to the 10th. And then make sure you label it pounds. A hydrogen atom has a mass of 1 67 hundredths times 10 to the negative 27th kilograms. What is the mass of 6 times 10 to the third hydrogen atoms? Express the result in scientific notation. Pause the video, try this one, compare your answers to mine. All right, 1 67 hundredths times 6 is 10 and 2 hundredths. Then negative 27 plus 3 is negative 24. Then my my decimal is in the wrong spot. It should be here between the 1 and the 0. Now, from where it currently stands, I need to move it 24 places to the left. From where I want it to be, it needs to move 23 places to the left. Then I need to make sure to label it. What is the mass? We are going to say kilograms. All right.